start looking at a case 3 example, and we are still dealing with arithmetic sequences, right? So this is going to be case 3. So what defines a case 3 example? Well, the first thing is that the sequence is given, but it's not straightforward, right? So when we say the sequence is given, we mean there are 3 consecutive terms given. However, it is given with a constant unknown in the sequence. Constant unknown in the sequence. And we're going to see an example of this in a moment. There's a constant unknown in the sequence. And this is really what a case 3 example looks like, right? That's the first thing. The second thing is the types of questions they would ask you is calculate the value of the constant unknown. So, or determine the value of the constant unknown. I'm going to call this constant unknown x, right? So yeah, they can ask you, give me the value of x. And then finally, the other questions they can ask is any case 1 questions once you've found that. And then the last part is the following. The last part is the following. How do you solve questions of this nature? You solve questions of this nature by using the defining property of the sequence, right? So I'm going to put here use defining property, and we will see what that means in a moment. What makes an arithmetic sequence arithmetic? It is the constant difference. And the only thing I didn't mention here is the type of sequence must also be given, right? So I'm going to put there plus type. The type of the sequence must be given. So you're given the terms of the sequence, but inside the terms of the sequence there's a constant unknown. And with that you're also given that it's either geometric or it's arithmetic or whatever it is, right? Calculate the value of x, any case 1 questions, use the defining property of the sequence. Okay, so those are the 3 properties. Those are the 3 things. The sequence is given, the type of the sequence is also given, there's a constant unknown in the sequence, the types of questions they can ask you is calculate the value of the constant unknown or any case 1 questions that we've previously discussed. So let us look now at an example, and I'm going to write down the sequence here. I'm going to say that the first term of the sequence is x plus 1, the second term of the sequence is x plus 4, the third term of the sequence is 2x plus 4. Okay, so this is T1, and I'm just going to label it as such. And this is T2, and this is T3. Right, now you are given this, and the question will say something, given the sequence x plus 1, x plus 4, 2x plus 4, and the sequence is arithmetic. I'm going to put there, they tell you it is arithmetic, and these are the properties that are given, right? Determine the value of x. Now, when we have questions like this, remember I said you use the defining property. So let's just go back. The defining property for an arithmetic sequence is T3 minus T2 is equal to T2 minus T1. Okay, that is Tn minus Tn minus 1 is equal to Tn plus 1 minus Tn. In other words, if this is 2, then you say T3 minus T2. If you put 2 in n, then that's going to be T2. This is going to be T2 plus 1, which is T3. And if you're going to put in T2 in here, then you get 2 minus 1 is 1, and T2 minus T1, etc. Right, so this gives you the same property that you see over here. In other words, every subsequent term minus the preceding term must equal every subsequent term minus its preceding term. And that there is what we call D. Common difference. D is equal to this thing, right? So remember, this is what we call the defining property. It's what makes an arithmetic sequence arithmetic. So let's go one back and let's say, okay, to solve this type of problem, we first have to recognize what type of question it is. It is a case 3 question where I'm given 3 terms of the sequence, I'm told the type of sequence, and from that I can now determine to say, okay, I know that this minus this must be the same as this minus this. So we're going to say T3 minus T2 is equal to t2 minus t1. And now we just substitute in those values and we say, okay, t3 is 2x plus 4 minus, and remember if you're going to use, I can leave out the brackets in this part, but if I put a minus before a term, remember I must have the brackets there, t2 is x plus 4 is equal to x plus 4 minus t1, which is x plus 1. Okay, at this point it becomes pretty trivial to solve. That's going to give me 2x plus 4 minus times an x is minus x, right, minus 4 is equal to x plus 4 minus x minus 1. And now we just add up all the like terms. It's 2x minus x is just x. That cancels with that x. I'm left with a negative x on this side. 2x minus x is just x. Minus 4 plus 4 cancels out, so I'm left with x on that side. And then x minus x cancels, and I'm left with plus 4 minus 1. Plus 4 minus 1 is equal to positive 3. Okay, and so that's what we found as the value of x. Now what you do is you substitute it in to check if the solution is correct. X plus 1, x plus 4, 2x plus 4. So let's just put that over there, x plus 1, x plus 4, and 2x plus 4. And let's substitute that. Let's just make sure x plus 4, 2x plus 4, x plus 1, x plus 1. Let's substitute in our solution. We found that x is equal to positive 3. If I put in there 3 plus 1, 3 plus 4, and then 2 times 3 plus 4. And what do I get? I get 4, I get 7, and I get 2 times 3 is 6, 6 plus 4 is 10. And now I can test to see whether I actually receive or get an arithmetic sequence. So I got 4 and 7, that gives me 3, and 7 and 10, that also gives me 3. At this point I can now say, perfect. This value of x actually yields an arithmetic sequence. Now, if you solved for x and you back substitute, you check your solution and it's not arithmetic, given that they told you it's going to be arithmetic, then you know that you've made an error somewhere. So that's an example of a case 3 question. Remember, the sequence is given, they tell you the type of the sequence, but there's also a constant unknown. Once you've found the value of the unknown constant, we can now clearly say that it is a case 1 question from here on. Right, so any question related to case 1 can be given to you from here on.